Okay, last but not least, 6.7 rates of change in trigonometric functions. Again, folks, we use the same thing that we've done for rates of change. It feels like ad nauseum. We've been doing it for a long time. Basically, the average instantaneous rates of change of a sinusoidal function can be determined using the strategies that were used for other types of functions. So, look at a sine graph. This is something to note that's really important. The steepest tangent line will occur at the equation of the axis. For either the cosine or the sine, it will always occur at the equation of the axis. Because if I was to take, for example, one of these tangent lines, let's just try and grab a tangent line here. Okay? And I'm going to take this tangent line and adjust it. So what's going to happen is this tangent line literally can follow the graph. So we start at a horizontal and we move so that the tangent line will move according to the graph. Okay? According to the graph, according to the graph, and again you're moving according to the graph. And what will happen at the equation of the axis is this particular tangent line will be at its steepest point before it starts to slow down again. So the idea is that you've got this tangent line that will be at its steepest at the equation of the axis. A horizontal tangent line, obviously, was going to occur at all the max and mins along the sine, cosine, and tangent. So what we need to find is what the values are for the instantaneous rate of change and the average rate of change. So looking at an example on page 371, number 8, it asks you something about the idea, is the value going to be positive or negative at certain values. 1/200 is the final value. So, at what intervals will there be values? 1/200 means that half of that is 1/400, and half of that again is going to be 1/800. So you have 1/800, 1/400, 1 over, and let's see what the next value is going to be. 1/400, we need to find a value that goes here. And that should be 3/400. 3/800 would be the value over here if we're to divide this into 4 parts. So the first part would be, which is about here, would be 1/800. Then there's 1/400. Then 3/3 over a certain value, which would be 3/800. So, and we would find the value for that. Okay. So we need to know the equation of this function. The reason we need to know the equation of this function is we want to be able to calculate whether the slope of this is going to have a positive, negative, or a 0 value. Now, over here, we could actually look at this graph and say, I know that at certain values I'm going to have a positive instantaneous rate of change, and at some levels I'm going to have a negative instantaneous rate of change. And that's how you would approach a question if you didn't have higher needs to be able to figure it out. Or stronger equipment to figure it out. You don't need a graphing calculator to figure this out. You should be able to look at logically which slopes of the tangent lines will be positive and which slopes of the tangent lines will be negative. Alright, so 2 pi over k, this whole function has the length of 1/200. So we solve for k by multiplying k by k and dividing by the period, and we end up that k is equal to 400 pi. What that means is, in terms of our equation, you're going to have 400 pi over here. Now, over here, 8, this a and the c value will not affect our transformation or our values that we're trying to find. So, there's our equation. We need to know when it's positive and when it's negative. So the instantaneous rate of change. So what I did is I found an equation and we let A equal 1 and C equals 0. Because if the amplitude is 1, we know it goes from 1 to -1 or whatever it may be. But then the C value is 0 because a vertical translation will not affect our question. So I find the instantaneous rate of change using coordinates as opposed to a graph. And we find out the value is negative. And here is the sorry, folks, here's the actual answer, but the value is negative, and that's the main thing for the instantaneous rate of change for this question. It asks for, will the value be positive, negative, or 0? In our case, it's negative. All right, so that's 6.7. You guys should know how to do instantaneous rate of change and average rate of change. This should be nothing new. We've done it for so long. With the exception of the denominator, just be careful. When you're using the secant and you're trying to find the secant, the denominator has to stay in radian form. It's the numerator, if you're using a degree where you involve sine, cos, or tan, that's the only time you have to use sorry, I just lost my train of thought. So basically, keep in mind that when you use sine, cos, or tan for average rate of change, the denominator stays in pi form. The only time you convert to degree mode is when you have the your regular calculator in degree mode, and you have to find the sine, cos, or tan of that angle. All right, folks, that's the end of the video. Take care. Have a good night.